In the last video, we were trying to estimate this probability of if we roll 4 different 6-sided dice, what's the probability that the biggest value is 5? And so there are four different dice, each with 6 possibilities. So total, there are 6 to the 4th possible combinations of like 1 through 6 for each of the dice. So it's fine to actually just go through all approximately 1,300 of these possibilities and count how often is the biggest value 5. So that's what I want to do in this video. So this will be the exact probability as opposed to the probability estimate from last time. So what we expect to get is something around 0.285 approximately. So I need some way of getting all 1,296 different quadruples of values from 1 to 6. So let me show you just an idea of how we could try to do this. We could say for I in range 1 to 7, for j in range 1 to 7, for k in range. And anytime you find yourself typing the same thing over and over again, you should think that you're probably doing something wrong. In general, in programming, it's almost never correct to like write out the same thing over and over like this. But let's just check. So all dice, I'll make that as an empty list. And so I will be something from 1 up to and including 6, j the same, k and l the same. And so for each of those, let's put it into all dice. So what I'm going to append onto all dice is this quadruple I, j, k, l. And for example, let's check what's the length of all dice. Okay, so there's the same 1, 2, 9, 6. And let's look at it. All dice. And let's use indexing, and let's just look at the first 10 of these values. And so what's happening is I is set equal to 1, and then we do all of this stuff. J is set equal to 1, and then we do all of this stuff. So what I'm expecting to see is I, J, K are 1, 1, 1, and then L should be changing. Okay, and then I guess K will change to 2, and then L will start changing again. Okay, but I and J should be 1 in everything we see here. Okay, so this is I, this is J, this is K, this is L. And if it doesn't make sense why these are the numbers we get, it's worth staring at this and thinking about it. That's an important skill, to be able to read a for loop like this or some nested series of for loops and figure out what's going to be produced. Okay, so we could do this, but let me show you some better ways we can do this. So I'm going to use an external library, but this is not one you have to install. It comes like pre-installed in Python, and it's called Itertools. And so a lot of times what we do is we say import and then whatever we want, import Itertools. In this case, I'm only going to be using a single function from this Itertools library. So I'm going to use a little different of a syntax. I'm going to say from Itertools import product. Okay, and now I have access to product. You can check it out like this, help product. Okay, this is from the module Itertools, it's telling me. And here, notice this keyword argument, repeat equals 1. So let me do product range 1 to 7. And let me say repeat equals, let's just do 2 to start. So this is what's called an iterator. And we can like iterate through all of the different, in this case, all of the different length 2 tuples that this product is going to produce. I know, but if I want to see it as something a little easier to understand, I can convert it to a list. And so here is 1, 1, 1, 2, and so on. Okay, and so this is a much more elegant way of getting these all 1s, then 3 1s, then a 2, and so on, from that we got using our nested for loops. So let's call it, how about temp list equals, and I tried to do this with without converting it to a list, but it didn't work. So I'm going to convert it to a list. And so range 1 to 7, and then repeat equals 4. So up above, I said repeat equals 2, and that was why we were only getting length 2 tuples here. And product, you should think of this as Cartesian product. So it's like Cartesian product of this range with itself. Okay, you could also do, for example, product, and then let's say A, B, C. And then instead of specifying repeat, I'm just going to say, how about the numbers 5 and 6? And let's convert it to a list. And I hope this will look like a Cartesian product, at least if you've taken something like Math 13 and seen Cartesian products. So we have A5, A6, B5, B6, and so on. Okay, well, whereas if we do, forget the second one and say repeat equals 3. And then let's see, what have I done wrong? I'm missing one parenthesis. Hey, then this is like the exact same as saying, give me the product with this ABC repeated 3 times. Like because of the quotes, I don't really want to type it 3 times. Okay, so the repeat is a more elegant way than like pasting it in 3 times. Okay, but this is the one we really care about. So let's call it temp list. Okay, and let's check. I want this to be the same 6 to the 4th as before. Yeah, so this is 1296. Perfect. And so let's convert it to an array. I'll call it ARR equals np.array temp list. Okay, and let's see what is ARR.shape. Okay, can you predict this? Well, each of the tuples has what length? Each of the tuples has length 4. And how many tuples were there? There were 1,296. So this should be 1,296 rows by 4 columns. Yep, so that looks good. Okay, great. And so now we can do ARR, I almost did dot shape, but that's not right. Dot max axis equals 1. And then I want to know, how often is that equal to 5? Okay, and then I can take that and divide it by 1296. Let's do, to make it a little more robust, let's get the 0th element out of this tuple. Okay, so that's going to be the exact same as the number of rows in whatever ARR is. Okay, and what I'm hoping is that this gives me something very similar to this 0.2849 number. Let's see. Okay, and what have I done wrong? Oh, I forgot to sum it. Okay, and here is 0.284. I guess what I was doing in the last video was this dot mean. That also would have worked. Let me show you just one more way of how we can compute this more mathematically without having to use any computers. We can say, so I want to know what's the probability that the biggest of the 4 numbers is exactly 5. So the probability that all of the numbers are strictly less than 6 is, well, any given number, it's 5/6 for the probability that it's not 6, and then 5/6 to the 4th. This will be the probability that there are no 6s in the length 4 tuple. And then we want to know, given that, what's the probability that, or let me not say given that, then from among these possibilities, I want to know what's the probability that the biggest number is exactly 5. So one way I can think to do this is I can just subtract the probability that all of them are less than or equal to 4. Okay, so that'll be 4/6 to the 4th. Okay, so this is saying, what's the probability that none of the values are 6? And then I'm subtracting that, the probability that none of the values are 5 or 6. And so when I subtract that, I'm getting exactly the probability that at least one of the values is 5, okay, and none of them are 6. And here we get that exact same 0.2847 number as before.